So, who can raise their hand and tell me, when I'm looking at a box plot, who can raise their hand and tell me what are each of these increments? 25%, right? Can I see how many people I surveyed or asked about this data? No, right? All I know is that I took the data and I separated it into 25%. So the top, the middle, and the bottom 25%. So what percent of the households were charged between $20, so right here, to $40? So how many increments do I have? 1, 2, 3. So if they're each 25%, what percentage of the households?
75.
75. And so Jordan, you're going to answer the next one. What does IQR stand for, Jordan?
Interquartile range.
Beautiful. Interquartile range. And I give you that equation, which is Q3 minus Q1. So Jordan, what is your Q3?
35.
35. Minus your Q1.
20.
And what do you get? 15. And we're going to be working a lot with the interquartile range today. So how many people got that 15? Cool. All right, next one says, it's talking about two different box plots, but here these stars, you might have seen them on your ITEL, mean outliers. So today we're going to be learning how to calculate outliers, but if you see little stars like that, it's considered an outlier, which means it's way bigger or way smaller than the data. So they're saying exclude them, so don't even look at them. So they're saying which class has a larger range. And so we can either subtract the highest, the max from the min, or I can figure out, okay, this one goes from 20 to 50. What is 20 to 50? How far is that apart? 30. And this one goes from 15 to 45. How much is that apart? So it goes from 45, or sorry, I was wrong. It goes from 15 to 60. So what from 60 minus 15, what do you end up getting?
45.
45. So which one has a larger range? Tracy's class. So remember, it's just your max minus your min. Okay, so that part of on your checkpoint assessment, there will be your checkpoint quiz is just 3 mini quizzes combined. So it's not really a big test or anything like that. It's kind of just a checkup to see how we're doing, since we're not doing it every day anymore. And so this sort of stuff will be on it. So now we're on our pink sheet, and so what you're doing is you're folding your pink sheet into Gabby's like this, and you're folding it until it says mean absolute deviation. So there should be mean absolute deviation. So when you open your notebook, it should look something like this, where it's in the margin. So not completely in half, but like where this is sticking out. And so we're going to be gluing this, taping it in a few minutes into our book. But fill in the red blanks, and I'm going to explain to you what this means. And so it looks something like this. You are going to need a calculator today too, so if you have your own or you just borrow a yellow one, make sure you go get that ASAP. We are going to be doing a lot of calculations today. So what we're doing today, it's called mean absolute deviation, and you're kind of given this formula on your formula sheet, so it's not really any memorization. What you're figuring out is you're figuring out how spread out your data is. So if I was looking at your unit 4 tests, and some of you guys got 100, some of you guys got 70s, some of you guys got 0s, it's how spread out your data is. So we're trying to figure out from the mean, from the middle of your data, how spread out is each data point from the mean. And so that's what mean absolute deviation means. And absolute, what's absolute value mean? Does anyone know? Like these lines. So if I had like this, what does that mean?
Oh.
Come here.
It's in between. Like I said, maybe it's 5 and then the line.
So it's 5 away, right? all absolute value means is make it positive. And so how I remember, if you have something like this, I just remember these lines slice off the negative. So what would this answer be? How far away is it from 0? 5. So it doesn't mean change the signs, but it means make it positive no matter what. That's what absolute value means. So how we do this is first we find the mean of the data set. So what I would do, since we are going to be working with outliers too, is you can go to that purple sheet, you come under, you click stat, edit, and you enter your data points. Or you can add them all up right here and divide by the number of data values you have in your set. So however you want to do it, you can add them up and divide by how many numbers, or you can do that stat edit, and when you're looking at finding the mean, it looks like this. So it has an X with a line on top, and that means your mean, or your average. And so either add them up and divide them in your calculator, or type them in that table, in that stat edit, and find what exactly it is. Okay, did anyone find it so far? What did you get, Sayuri? 83. Did everyone else get that? Cool. Is anyone having trouble finding the mean? So you add them all up and divide by how many numbers, or you can put it in your table stat edit and go through. And when you see something like this, the X with the line, that means mean. Now, what I'm doing is I'm finding the distance, and it has to be positive, right? Because it's just a distance away, how far away each of my values are, each of these scores are from your mean. So 83, I'm figuring out how far each of these numbers are from 83. And so you can subtract them, and then whatever the value is, make it positive. Or you can go, okay, how far away is 95 from 83? 12, right? So I put 12 right here. And so you're figuring out how far away is 90 from 83? 7, and keep going. So you should have all positive numbers. Even if it's negative in your calculator, and you're subtracting them, make it positive. That's what absolute value means. So you're finding the distance from mean. And so you should end up with something that looks like this. Look up when you're done. So once you're done with those numbers, the last thing you do is you actually find the mean of those distances. So how do you find the mean? We add them up and divide by how many numbers. So we're taking all of our distances from the mean and finding the actual mean of that. Plus 12, plus 17, plus 33, all over. And how many numbers are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So when you get this, when you add all these numbers up, what did you guys get? 13. You got that as your answer. What about one before I divide by 10? 134. And then divided by 10 ends up being 13.4. So your mean absolute deviation, which means how far, on average, how far are each of your data points from 83. On average, they're around 13.4. And so the bigger that number is, the more spread out your data is. The bigger that number is, the more spread out your data is. So they use this to find like statistics all the time, to trying to figure out, okay, if I'm looking at each class and I want to figure out how you guys did on the test, if you guys all got around a 70 and your mean absolute deviation was pretty small, that means as a class we pretty much know 70% of the material. But if your mean absolute deviation was all over the place, that means there's probably some misconceptions going on because people are doing really low and people are also doing really high. And so that's what that number is. And so you're given, when you're done, you're going to put this, I'm going to go one thing at a time. So we're going to be going to the green sheet next and practicing with that. So skip over the first part. And so it says measures of variability right here. And so this thing right here, this thing, I don't know, I have a choice on my board, you're given that on your formula sheet. So this is what you're given on your formula sheet, and you're like, ooh, what does that mean? They tell you right here. The sum, so what does sum mean? Adding of the distances between each data value and the mean divided by the number of data values. You're given that on your formula sheet. Now, you just need to make sure you're practicing and remember, like, what does that mean and how do we do it? So we're going to be practicing with that a little today. And so the bottom two are what I want you guys to start with. Actually, I'm on top. Yeah, so the bottom two on this page is what I want you guys to start with. So you're just practicing that same skill. So we know that mean absolute deviation is the distance. We already kind of wrote these notes, but in case you read them again, each value is from the mean of the data sets. This helps us sense of how spread out the data is. And so here are our test scores. We have student R and student S. And so instead of typing it 2 different times, if you're doing it in the list, use one as L1 and one as L2 when you're typing it in. So you can use L1 and L2 when you're typing in your data numbers, because you're finding the absolute deviation of both student R and student S. So when I'm looking at this, here's student R. And so I'm going to write all student R's data down. So her data was 3, 6, 8, 8, 9, 10, and 12. And the other one was 1, 1, 3, 7, 14, 15, 15. So first you need to figure out the mean. And so you can either add them all up and divide, or you can put it in that data chart. So you can try that out. So your student R, your student S. Yeah, and then you would just do it, you would do it one at a time. So if you're doing, I would type L1, L2, you could read that one. So there's one number, right? So then if you want to see L2, and that. So you can change the L1 and L2 when you use that. Beautiful. Probably the same. See? So, did you guys find the mean of the first one yet? 8, right? So you're just going to write 8 all the way down. What about the second one? It's also 8, right? So they have the same mean. Now we need to figure out, do they have the same variability, which means how spread out they are. And so you don't need to really put difference. They're just saying if it's negative, make it positive. So you only really need to fill in that positive value place. So you're just saying how far is each number from each other. So like how far is 3 from 8? 5, 5. So that's what you're figuring. And then at the end, they're asking which one has this data is more spread out. So you're figuring out, looking at that mean absolute deviation, whose data is more spread out. So how far is 6 away from 8? 2, 8 from 8, 0, 0, 9 from 8, 1, 10 from 8, and 12 from 8. 4. And then you find the sum, which means what are we doing with all those values? Adding them. So what's 5 plus 2? Plus 1, plus 2, plus 4. 14. And count means how many numbers. How many numbers are there? How many data points? 7. And so what is 14 divided by 7? 2. So your absolute mean deviation would be 2. Now you're doing the same thing over here. For this one, the mean. So both of their means end up being 8. Yeah. Just so. Okay, so let's read down this list. What do we get? 7. What else? 7. 5. 1. 6. 7. And 7. And what did you get for the sum? 40 divided by 7. What do you end up getting? 5.7. And so which number is bigger, 5.7 or 2? 5.7. So that means that on the next page you're just answering that. So since 5.7 is bigger, that means student S or student R is her kids or her smaller or larger. Smaller. That was the first one we did. It's on the page. So here's this right here. So we can see that their mean absolute deviation is smaller. So is their data more spread out or more consistent? More consistent, right? So consistent, it means the smaller this number is, the more consistent it is. And so I would write smaller and they're more consistent. Okay, I'm going to have you guys try this one on your own. There is going to be decimals, so just be aware of that. So you're just doing the same exact thing, just these 3 problems, or just pick one. You can pick one and do it. So there's 3 of these. There's one right here, and there's 2 down below. So don't do the multiple choice question. Choose one of them and see if you can try to find the mean absolute deviation. So there's 3 on your paper. There's 1 at the top and 2 at the bottom. Pick one of them for right now. I just want to make sure you guys can practice and know how to do it. And then I'm going to teach you the second part of the lesson. So choose one of them. You can choose this one and see if you can get the mean absolute deviation. I'm going to pause this real quick. So who can raise their hand and tell me, what do outliers mean? Or
the numbers that are really, really high or really, really low.
Really, really high or really, really low, right? And so there's a formula that we use in order to figure out, is this number really, really high or really, really low? And so sometimes, like on IXL, I'm pretty sure 2 of them are outliers, and you're able to tell, like it's like 4, 5, 6, and 1,200. So some of them are super obvious, but some of them are not. And so the formula that we use looks like this. And so to find the small outliers, like if they're really, really small, they would have to be smaller than this. So Q1 minus 1.5 times your IQR. And so if your data is smaller than that answer, then it is an outlier. It's a small outlier. If your answer is larger than this one, then it's a big outlier. It's part of the formula. So basically what they're doing is they're finding the interquartile range and they're multiplying it by 5.5, basically. And so they're trying to see, that's what they consider an outlier. And so this formula I won't give you, and it's not going to be on your formula sheet, So you do have to remember, okay, if I'm finding an outlier, it's either going to be super obvious, or I know I need to multiply 1.5 times IQR, and either add it to the Q3 and subtract it from the Q1. And so all you have to do is you plug in your values once you find them. So your Q1 here was 23, right? So I'm going to put 23 right here instead of Q1. Mine is 1.5, and I need to find my IQR. What is IQR? How do I find that? Q3 minus Q1. So here our Q3 is 32, our Q1 is 23, and what do we get? 9. So that's what goes right here. You can put that right into your calculator. Raise your hand when you get a value. So what is 23 minus this right here?
9.5.
What do you get?
9.5.
9.5. And so we see that our minimum is 13. Is 13 smaller than 9.5? No, so we have no small outliers. So no small ones. Now we need to see, are there any large outliers? So I'm using Q3, which is 32. So I do 32 plus 1.5, and what was your IQR? 9. Let me know when you get that answer. You can literally put that right in your calculator. Warren, what did you get?
45.5.
45.5. Now, what's your max here? 55. Is that larger than 45.5? Yes, so we know that this 55 has to be an outlier. So any number that's larger than 45.5 is going to be an outlier in this data. And so we know since our max is 55, that number's got to be an outlier. Does that make sense? Okay, let's do the other two together, and then I'll give you guys time to practice. So you're going to keep going, just maybe draw a line. Now I'm going to do your data with the next example on the purple sheet, which is example 6. And so who can raise their hand and tell me what the min and the max are? We already did this, so it already should be just written down. Example 6.
74. 74 and 99.
74 is your min,
Mm-hmm.
and 99 is your max.
Yep.
Okay, what's your Q1?
75.
75. Is it? Everybody? Is it 75 your Q1? Is that what you put? Right here. 75.5. We're using the data you already have.
My max is 99. My Q1 is 74.
That's 86 is
Oh,
your Q3.
oh.
And then your Q3 is 83. Or what was it? 86. So I'm just reading off your purple sheet. So if you add this up right here, you already did this data. So I'm taking your example for your purple sheet, and we're trying to see, are there any outliers? So first, I need to find my IQR. How do you find your IQR? Good. So 86 minus 75.5, which is Q3 minus Q1. And what do you end up getting? 10.5. So that's your IQR. So you know that we're taking our Q1, which is 75.5, and since that's the smaller one, I'm subtracting 1.5 times your IQR, 10.5. And we're trying to see, is that number going to be smaller than 74? Then I'm taking your Q3 and you're adding this to it. And you're trying to see, is that number going to be bigger than 99? So see if you can get those. You can just type it right into your calculator, see if you can get those two values.
You have to write down example 6.
Yeah, I would just keep writing it down on your paper just so you have something to look at. Or you, I wrote it right on my purple sheet. If you want to write it right on your purple sheet.
59.
So that's the smallest one. So the small one, you end up getting 59 point what?
75.
75. And so is that number smaller than 59.75? 74? No. So there's none There's no small outliers. Then let's add it and figure out, is 99 going to be bigger than this number? What number do you end up getting right here? 101.75. So is 99 bigger than that number? Nope. So are there any outliers? No outliers. So you're basically just using this formula to figure out, are there any really, really big numbers or really, really small numbers based on this data? All right, try the last one on your own. You can either do it right on your purple sheet, or you can do it on a separate sheet of paper. I'm going to come around and stamp for this. So that's example 7. Yeah.
So answers are supposed to be bigger or smaller.
So this is like your formula. Q1, you're taking your first quartile, right? And you're subtracting that little concoction, 1.5 times your IQR. And so you're saying, okay, if any of the numbers, any of the data points are smaller than 59.75, then it's considered an outlier. And so when you look at the line of numbers, you can see that the minimum, the smallest number, is 74. So is 74 smaller than that number? 59.75? No, so that's not considered an outlier. Then we're trying to see, is 99 that max considered an outlier? So I used this little concoction right here and got 101.75. Is that number bigger, or is that number smaller than 99? So 99 has to be bigger than this number right here. So
Both have to be smaller.
So this number right here, 59.75, has to be, the min has to be smaller than this number, and this max has to be bigger than that number. And so we're trying to see, these are their cutoffs for the smallest and the biggest. So if they're bigger than this or smaller than this, they're considered outliers. And so now, does anyone need the data for example 7, or just want to make sure this is right? Or can you guys try it on your own? Does anyone need the data?
Can you scroll back up?
Mhm. So see if you can try the last one, see if you can see if there's a big or a small outlier. And you could do it right on your purple sheet if you want to. And then after that, you're using this formula and figuring out, okay, is there any number bigger? Is this number bigger than what the outlier formula says? Or it isn't? Then you're seeing this number. All right, so you're trying the last one on your own. So right here you got 70. So you got 61, right? So this is a smaller one. This is cracked right here. Is any number of these numbers smaller than 61? So that is considered an outlier. Then there's no big outliers. So today's deliverable, shh, girls. So I'm explaining this last thing, and then you have time to practice. And then if you want to get started on your IXLs for today, you can. And so the last part of your deliverable is right here where it says data. So you're finding the mean absolute deviation of your guys' salaries. And so we learned how to do this through the pink sheet. We learned how to do it through that example. So I want to make sure that everybody has the right data. So I'm going to use Gabby's packet and put it on the board. So these are all the salaries or what you're putting here. So for example, this one would be 68,450. So I would make sure to write this down in case you don't have the data. 186,000. So you're trying to see how spread out these salaries are. After that, girls, listen up. After that, you're going to find if there's any outliers. So you're using the formula. That's why I would type all these numbers into the stat button. And so it's because you are going to have to find your Q1 and Q3. So then you're trying to see, are there any outliers? And you're answering on a Google form 2 questions about this. And so all these deliverables, you're like, oh, this is a lot. This is all you're doing for the rest of the class. But there's going to be, I give you 2 grades. One's a written communication, one's an agency. So one's agency for just doing it and solving it. And the written communication is showing me, like, can you explain through writing what we're doing and like why we're doing it? And so I'm going to write the salaries on the board. So make sure you're following along so I don't have to keep scrolling up. So I'm just going, if you know you have them all, then you can go by yours. So here are all the salaries that you guys had got. So make sure you're writing these down on your table on your budgeting packet. So those are all the ones that I have. And then you're fine. I would put them all in your stat edit because you are going to have to be finding the outliers. I'm going to change this real quick just so I can stop recording. But you're going to be going to Google Classroom, and I sent it out. Listen up this last time. I sent it out through Remind. So if you go on Google Classroom or through Remind right here, this is your written communication. So the first question is, what did you find your mean absolute deviation of your classmate's salary? And what is the significance of this number? And then the second question is, did you find any outliers? Why would these salaries be considered outliers? So those are your 2 written communications for today. Yeah. How many are on there?
I have 16. I have 16.
Is there somebody that's missing that, like, you know your salary's on here?